Well, hi folks, it's Cliff here, a toolmaker from Down Under. Well, this video is going to have details on screw thread accuracy, lathe lead screw accuracy, and the accuracy of the thread on the spindle of Threadexpress is going to be tested as well. Fascinating subject. I also want to mention that the plans and the technical drawings for Threadexpress are now available if this is fairly new to you. Have a look at the end of this video and I'll go through how you can navigate to my website and download the technical drawings and other files. Threadexpress is reassembled as a version 2.3 with an upgraded spindle with an ER32 spindle nose, and I'm going to do some testing in this video to see how accurate it is, and also go into how the scales are produced and calibrated and how that side of this unit works. If Threadexpress is new to you, I'll run a short clip now giving you one example of what Threadexpress can do. Set the pitch on the single nut adjustment on the scale to, in this case, to 1.5 millimeters pitch. Wind in the slideway until the cutter is inside the valley of the thread using the Z adjustment, either with the knee or the quill, until it's in a line, and then I'm ready to go. Thread milling with a tungsten carbide fly cutter can easily handle high tensile steel. Well, we have version 2.3 back together. I think version 3 with the aluminium base will be quite a bit lighter, but still this is not too bad. Just slip it in there. Simple as that. Couple of bolts and we're ready to go. So I know a lot of folk have been asking, well, what if you don't have a Bridgeport style machine with a turret? How can we make it fit a different type of mill, like a mini mill? Well, I've thought a lot about this and there's been a lot of comments. One idea is to get a right angle attachment for your mill. Or another idea is to tip the head around at 90 degrees. And the other idea, of course, is if you have a horizontal spindle or a horizontal mill, then it can sit on its base on the table with those three different arrangements. So installing Threadexpress is a quick job, but you could also leave it there because it's well covered with the guards. Whatever suits your situation. Then it's just a matter of pulling around the turret and you're ready to go. Tighten up the little bolts that hold the turret tight and you're set up ready to go. Right, so I've got it mounted up on the mill now and I want to do some accuracy tests, but maybe I should take you along for the journey and show you some of the steps involved. So this cover, just take one screw off to remove that cover, and that allows access to the adjustment of the infinitely variable pitch there. You can see the threads per inch scale on the bottom, and for disconnecting the transfer plate for plane indexing. Let's go through some of the controls. It's showing the direction of raising the attachment vertically on its lead or helix, and down there you'll see I've got a dial indicator, a long travel Mitutoyo dial indicator, and that is for checking to see how accurate the pitch is. So if you look down the bottom here, you can see I've got an articulated arm with an adjustable plunger on it, and the idea of that is it makes it quick and easy to reset the position so I can do long travel trials and measure just how accurate it is here. So multiple rotations are the way to measure these sort of errors, to see if there's any accumulated errors. Here you've got the little lock screw pretty basic. Probably should have like a lever on it, but this is just a temporary little hexagon lock screw. When I want to do indexing, I can lock the slide and disconnect those bolts there so that we get lost motion under the transfer plate. So they're the key controls. Not a lot really, just a couple of bolts at this stage. So I'm going to do some long travel accuracy tests now. You remember I've done a video, half a dozen videos ago, Threadexpress accuracy and durability, and even though the spindle that I had was pretty roughly put together with a loose fit on the nut, it was still amazingly accurate, but I was getting tiny errors of half a thou or a hundredth of a millimeter. Okay, well, let's test the accuracy of our reassembled version 2.3 with the refurbished spindle. Remember in a recent video, Threadexpress accuracy tested, accuracy and durability tested. I was getting pretty good readings there anyway, plus or minus a hundredth of a millimeter over a 50 millimeter traverse. But I've got a dial indicator here measuring the movement, and we'll come around to 0 on the dial. We'll set our adjustable dial there to 0. This is with the unit right down, so now we'll bring it up on a 2 millimeter pitch. So come to 0 there, we're on 0 there. We'll just do it in a series of stages over the traverse distance, 50 millimeters there and there, 0, 0. So if there was an error, you'd expect it to slowly get worse as we magnify the discrepancy. 0, 0. So I'm coming round to 0 on the dial here and checking it on the digital readout. That's that long travel digital readout. 0, 0. 0, 0. It actually really surprises me how accurate it is. So after nearly 50 millimeters of travel, I don't want to run off the still 0, 0. Now we're getting to the end of it. I don't know. I've just gone out of travel there. So that's better than a hundredth of a millimeter now with that refurbished thread. That's just astounding. That is more accurate than a lathe lead screw. I'll go into that a wee bit and see if I can explain what I mean. Okay, I want to put that in context briefly so you can see how remarkable that is. Of course, this may be in isolation. There may be a series of errors in the mechanism that all cancel themselves out, and other thread expressors may not be that accurate. It could be purely coincidence, but in this example anyway, it's remarkably accurate. If we look at the accuracy of these two lathes, which is an alternative method for cutting accurate threads using the lead screws, let's look at the test certificates. I've just looked them up, and for my more accurate HG28 lathe, there's an allowable error of 3.5 hundredths per 25 millimeters, or 0.035 per 25, or 0.05 per 100 millimeters. And the big lathe in the corner has a slightly less tolerance, believe it or not, of 0.04 per 200 millimeters or 0.02 per 50 millimeters. Of course, I've found errors exceeding that, but they're still quite loose tolerances. I've always loved metrology, and I've got to be careful I don't go on about accuracy too much. In the previous video, Threadexpress accuracy and durability tested, I put a memo there in the description and as a first comment. If you're interested, have a look at that. I go into it in detail. Here I've just put down some notes for a bit of a summary of that memo. Compare that with cutting a thread with a die. So I've done some testing of cutting threads with a die, and I think I've mentioned before in other videos that a die resists cutting and holds back on itself, and because it's relatively short it goes out of pitch quite quickly. So if you cut a long thread with a die in high tensile steel with a high speed steel die, you can get errors between 0.05 and 0.15 per 10 millimeters. Or even if you look at it per thread, 0.005, that's 5 microns to 0.015 per thread. So over a 50 millimeter distance, that's between 1/4 of a millimeter and 3/4 of a millimeter error. So, you know, cutting with a die, which is another method of cutting threads, is many times less accurate than on a lathe and on the tests I've been getting from that Threadexpress. Compare that with a digital readout, for example, and you're whole orders of magnitude different. If you could control your workshop to exactly 20 degrees, the tolerances, for example, for a Heidenhain digital readout scale is 10 microns per meter. That would be over 100 millimeter distance, 1 micron. That's 1/1000th of a millimeter. So we're not talking that sort of accuracy. With a lathe and with a die and with Threadexpress, we're a whole order of magnitude coarser, less accurate than that. Now I know some of you are probably wondering, well, how can you get that accurate with an infinitely variable scale with some lines engraved? See if I can go through that with you now. So let's zoom in on those lines. See the little lines there and the scale lines. They're quite fine lines, and you can see it's lined up on a 2 millimeter pitch where I did the test. Now you can imagine if the line was a little bit off that alignment, there's a long way to the next line, to the 1.75. So that's 1/4 of a millimeter between that line there, whoa, and there. So you can see, you can set that quite accurately. And of course this is calibrated by doing the mathematics and working out the spacing of the scale, and then finally the scales are in slotted holes. See the screws there are tightened onto slots, so then you can finally calibrate it into the exact position. So that seems to be remarkably accurate. Obviously if I bumped the line away from the 2 millimeter mark, it would not be accurate anymore. The dial indicator would show an ever increasing error. So it's down to the accuracy of the calibration of the scale position, but it's also down to the accuracy of the build itself. I'm not saying any Threadexpress will be that accurate, because it depends on the accuracy of the pivot mechanisms, you know, the fit of the sliding block and the circular pivot, the fit of the sliding yoke, the parallelness of the spindle to the slideway, a whole lot of little errors. In fact, there may be errors in this particular unit, but they're errors that cancel themselves out, and by coincidence it's just really accurate. I find it hard to believe that you could build 10 Threadexpresses and get that sort of accuracy each time. I think it's much more likely that this is a coincidence. It's also down to the accuracy of the Threadexpress spindle thread. You remember the original one was quite rough and thrown together. I actually machined it on that big lathe in the corner, which has got quite bad errors in it. I've subsequently found out by using the digital readout to check the lead screw, and remachined it on this HG28, which is much more accurate. So the accuracy of the master spindle thread is also probably a key factor. Well, while we're talking about scale graduations, now might be a good time to show you simply how the different scale graduation positions are calculated and engraved. So if we do a diagrammatic drawing of Threadexpress, here is the spindle thread and the spindle center line is that line there, and the pivot is on the center line there. This is the ratio arm, and this is the ratio arm pivot here. So on my prototype, I just made it and then measured the distance between the ratio arm center line and the center line of the spindle, and found it to be 206.65 millimeters. And this is with a spindle thread of 3.5 millimeters pitch. So we have zero movement there at the pivot. So if 206.65 gives a 3.5 pitch, then we can work out a factor. If we divide 206.65 by 3.5, we get a factor of 59.043. So if we multiply the factor by the desired pitch that we want to get, call that distance A, then we get that distance. So let's say we want a desired pitch position for the graduation line for 2 millimeters pitch. We get 2 millimeters times the factor, which is 59.043, and we get a position of 118.086 from the center line of the pivot of the ratio arm to where the graduation line is. And so you can very quickly calculate where the different graduation lines are for the different millimeter pitch or threads per inch. Obviously the difference between the two is just the factor of 25.4. Well, let's just talk briefly about what's available online. So if we go to our internet browser and start typing in the website address, which is hallmarkdesign.co.nz, we'll get to Hallmark Design's website. This is the website where I sell the probes that I make and so on. But if you look right over on the right hand side over here, you'll see Threadexpress. So let's click on there. Now, Threadexpress is a development hobby project and not part of Hallmark Design, but I'm using their website for this. So in the beginning you'll see links to the videos. You can just watch them directly here on the website. I don't think you get any ads if you do that, but if you click here down in this little bottom corner here, you can watch on YouTube. Let's just click over to there, turn the speaker off, or we'll get bombed with ads. Now if we look over here, there's all of the Threadexpress playlist videos. There's 18 different videos there, and you can click on those and watch all of those videos. Okay, so let's go back to the website. So now if we scroll down the page of Threadexpress, first of all there's a PDF that Mark and I put together, just sort of introducing Threadexpress, 2 pages of text there. And then if we carry on, well, let's just go through that quickly. So you can see there's information and introduction, Threadexpress history, notes on construction, files and license to build, and YouTube video links. Now if we scroll down a bit further, there's a bit of a memo here. Thinking of building your own Threadexpress, download of files and license. So some of you will be interested in this. It's a purchase by donation model. Click on the Buy Me a Coffee link below and enter an amount you think is fair. Some terms and conditions there. And then if we carry on down, there's the Buy Me a Coffee link. And then below that is all of the information. So we have 41 technical drawings. This is the main set of plans. So if we click here on the download, we'll just download that now. It won't take a second if my internet connection's working all right. Okay, so now we have 41 plans. So in the beginning there's some nice looking assembly drawings, and then we get down to individual components. So they are in PDF form, so you can print them out in A4, or if you want to go to a printer that's got A3, you can print them out full size. Maybe you want some of the parts printed out full size, and other parts can be just more compact A4s that you can readily stick on a clipboard in your workshop. So right down to finally some sub-assemblies here at the bottom. Mark's made a really beautiful job of these drawings. Okay, so let's go back to the website, and finally there's unusual files that can't be attached directly to the website, CAD files and other special files. So we'll just highlight that big long link there. See, it says here Dropbox files, link below, copy and paste to browser URL. So let's just go back to the browser URL. We've copied and now we're going to paste, and we did something wrong there. So let's try again. Copy. I'm talking too much and not thinking enough, and we're going to pop it in there at that top user URL, and see here the second one down is in black. We're going to click on that. That's going to take us through to Dropbox, and here you can see there's a folder that's opened and there's 4 folders within that folder. So you're looking at the Dropbox page, and let's say you want to download your files. So let's just click here on the top ones, the 3 support documents, just tick them there, and you can see here now you can download. Well, look, let's just download those files. Okay, so up here we have the downloaded files. Open the files, 3 support documents. Okay, let's click on those. So one of those is the stock list. There's stock parts that are available online, if you're lucky. So here Mark has made a list of different components. Here we are, internet links for off-the-shelf items over on the side here. So we can just click on this link that he's prepared. I'll do that now, the top one, 3-jaw chuck. Well, let's do the bevel gears, the second one. That's a bit more interesting. So that's going to take you straight through, in this case, to AliExpress, and you can see the bevel gears. Oh, that's brilliant, isn't it? And so that is the method for downloading. So you want the 5 files for the sheet patterns and sheet metal patterns and scales. Just click there, download to your computer, and then you can open them up with your CAD software, send them off to your sheet metal person to get them laser cut or whatever. Same for all the other files. There's photographs of different key components. Let's go back to, and there's some solid files here, 9 step files for some key components. Some of you will have CNC machines and may want to machine some of the parts up by CNC and drill holes and so on. Okay, so going back to the website, so then we have completed looking at all the various documents that are available. So the 41 PDFs directly on the website, and the link there to the Dropbox for the more complex files that can't easily be loaded onto the website.
Well, thanks for watching that video. I'm just checking you're aware that in Australia, Mark Presling has a channel, a YouTube channel, and he is also building a Threadexpress. Please let me know your thoughts. I'm really motivated by viewers' comments. It keeps me going. Please like and subscribe if you're not subscribed. That all helps to fire me up and keep putting in the hours to develop this attachment.